Okay, now let us do part 2. Now we have values that start with 0. So we are still writing from standard to scientific. Okay, so the question says write these numbers from standard to scientific. Okay, from there. Alright, write these numbers from standard to scientific notation. Okay, so we start by, now when you notice, these numbers are all going to start with 0. Okay, so this is the question. This is question 1. It says write this number from standard. So this is standard. And then you want to write it in scientific notation. Okay, so we said our engine cannot have 0. So the first 2 digits that are not 0 are 2 and 7. So I'm going to rewrite my question again. And whatever I am doing, you should also try and do that, so you avoid mistakes. So my engine is here. We said in your engine, the first digit cannot be 0. It cannot. Okay? It has to be 1, 2, 3, 4, 5, 6, 7, 8, 9. It cannot be 0. Okay? Now, here is your decimal. You want to move it over here. 1, 2, 3, 4. This is where it goes. Every number is under the U. Do you see that? Every number is under the U. So I recount 1, 2, 3, 4. Okay? This 4 is what I'm going to use it in my exponent. So I'm going to write 2.79 or 2 and 79 hundredths times 10 to the negative 4. How did I know it is negative? Because it started with 0. And I box my answer. Okay? All right, let's do another one. Let's do where we have, yes. How will I do this? So, in this is my question. So I'm going to rewrite it again. 1, 2, 3, 4, 5, 6, 7. 2, 4, 5, 6, 7, and then 2. So my first digit is here. And you see it is by itself because there's nothing over here after 2. So what will I do? I will put the decimal and I will put 0. So I want to count from this decimal to this decimal. How many times did I go? Okay. So I count 1, 2, 3, 4, 5, 6, 7, 8. Okay. I confirm by writing. This is me checking. Okay, so I know I went 8 times. So my coefficient will just be 2 because you don't need to write a 0 that is after the decimal. You don't need to write it. Times 10 and then 8 and then I check. It started with 0, then it is negative, and then I box my answer. Just like that. All right, another last one. We try a last one 3 times. So I'm trying to figure out. Okay, it doesn't matter. Let's do a small one. So So I'm going to write the question again. Where is my engine? My engine is on 3 and 5. I am coming over here. How many times did I move? 1 time. So I'm going to write 3 and 56 hundredths times 10 to negative 1. How did I know it was 1? Because I only moved 1 times. How do I know it was negative? Because my number started with 0. And this is my answer. Okay? And that is my answer. Okay. Is there another one I can do? Yes, there's one I can do. Write this in scientific notation. Okay, so this is 5. Where is the decimal? The decimal is here. Are you going to move it? No, it can't move. Because if I go this way, it will start with 0. My coefficient can't start with 0. Okay? And there is no other digits after that. So, did I move? No. So my answer is just 5 times 10 to the 0th power. And that is my answer. And how do I know I'm correct? 10 to the 0th power is 1. And 1 times 5 is 5. It's the same as the question. Okay? I did not move. Remember, you just write that. If you don't move, your exponent is 0. I did not move. And since I did not move, my exponent is 0. Okay? All right. Now, let us see if when we've been given scientific notation, how we are going to arrange them. Okay? How we are going to arrange them. Arranging scientific notation. Or comparing. Yes. So the question will tell you to arrange. Arrange. And how are you going to arrange? Either the question will tell you from least to greatest. So you must know how you're reading. Or from greatest to least. The question will say arrange from least to greatest or greatest to least. Or it will say arrange in ascending order. When you see the word ascending, then you should know you're going from small to big. When you see the word descending, meaning to go down, you're starting from big to small. When you see these words, you should know what they mean. Okay? Now, you've been given some scientific notation and they tell you to arrange them. So let's write examples. Okay. All right. So these are the scientific notations they've given you. You have this one with the exponent 7. And then you have this one with the exponent 6. And then you have this one with the exponent 6. Okay. And then you have this one with the exponent 7. Okay. Okay, so you're arranging, let's say we are arranging from least to greatest. So from least to greatest, you look at the ones with the smallest exponent. So the 6s will come first, okay? So these will come first because 6 is smaller than 7. And then the 7s will follow. The exponents, the powers with 7, okay? Now, when you look at this one, the coefficient is 1 and the coefficient is 7. So who is smaller? 1. 1 is smaller than 7. So I will start. So the least is 1 and 83 hundredths times 10 to the power 6 to the 6th power, followed by 7 and 15 hundredths times 10 to the 6th power. Okay? So this is smaller because this is 1 point. This is 7 point. Even though they have the same power of 10. Then I look at these two. I have 1.03 and I have 1.06. 1.03 is smaller than 1.06. Then I write it over there. 1.03 times 10 to the 7th power, followed by 1.06 times 10 to the 7th power. Now I have arranged all my numbers in order from least to greatest. Even though this is 1.83, which is bigger than 1.03, this is bigger because the exponent is greater here compared to here. 6 is smaller than 7. You compare your exponents, then you compare your coefficient. That is the rule. First, you arrange your powers of 10. Arrange powers of 10. After you arrange your powers of 10, arrange the coefficients. Arrange the coefficients. So, do not start by looking at the coefficient. No, you start by looking at the power of 10. And you group. Those who are the same, you group them together. So that when you're comparing, you don't make a mistake. I group them together. So when I'm looking, I start with the 6s, I arrange them. Then I looked at the 7s and I arranged them. When I looked at the 6s, 1.83 is smaller than 7.15. I write them there. 1.03 is smaller than 1.06. And now this is my answer from least to greatest, and I box it. This is our answer. The least value is this, the greatest value is that. All right, let's do one last one. One last one. Okay, so I have okay. And we are arranging from least to greatest. When I look at my exponents, the smallest exponent is, let's add another one. I'm trying to see. Yes. Let me add. Okay. And let me add another one. Okay. All right. So now we have how many numbers? 1, 2, 3, 4, 5. Okay. Now let's arrange these numbers from least to greatest. Who is the smallest exponent? The smallest exponent is negative 25. Negative 25 is the least value when it comes to my exponent. So I will start here. So the least is 4.62 times 10 to negative 25. After negative 25 is negative 10. Then I will do 2.52 times 10 to negative 10. So I have finished with these two. Then I have 3, negative 6, and negative 1. So negative 6 comes next. 7.85 times 10 to negative 6, because negative 6 is bigger than negative 10. Okay? After that, I will do negative 1. Okay, negative 1 is bigger than negative 10. It is also bigger than negative 25. It is also bigger than negative 6. So 1.92 times 10 to negative 1 to the negative first power. Then after that, it will be 2.72 times 10 to the third power. Why is this bigger? Because 3 is greater than negative 1, because 3 is a positive exponent. A positive exponent will always be bigger than a negative exponent. So this is your greatest value, this is your least value, and you box your answer. Just like that. Okay? All right. So, you have a problem over here. If you could walk at a rate of 2 meters per second, it would take you 1.92 times 10 to the 8th power seconds to walk to the moon. Is it appropriate to report this time in seconds or in years? Years, because from here to the moon you cannot go in seconds. It's going to take you a lot of time. So if it's going to take you a lot of time, the bigger unit is better than the smaller unit. If it's going to take you a lot of time, use the bigger unit. The distance from here to Dubai can only be measured in kilometers. No, you can measure it in centimeters, but it doesn't make sense. So if I'm reporting the distance from Al Ain to Dubai, I will use kilometers. I cannot use centimeters, okay? I can use miles, okay? So we are going from here to the moon. It cannot take us seconds. It will take us a lot of years to get to the moon, the distance, if I am walking. Yes? What if I am using, what is that called? The spaceship. If I am using a spaceship, so maybe it will take me days. Years will not be appropriate. You have to look at the question. You have to read. Think of the device that they're asking you. If I want to measure the length of this pen, I can use centimeters. Meters is not going to be appropriate. If I want to measure the distance from the gate to the front of the school, to where Idara is, I will not use centimeters, I will use meters. Okay? The distance from the gate to the Idara, I will use meters. The distance from the beginning of my pencil or my pen to the end of my pen, I will use centimeters or inches. Okay? Things that I use with the ruler. If I can measure with the ruler, centimeters, millimeters, like that. If I need a bigger tool to measure, then the unit has to be bigger. Okay? So you must know how to read. The question is asking you here to explain your reasoning. So we are going to the moon by walking. It will take us a lot of time. If I write it in seconds, I will fill out my whole page. Like I maybe need 10 more papers to write how many seconds it took me. So since I don't have that time to write all these, then I shorten my number using a bigger unit. So instead of using seconds, I will use years. So they say the measure 6.09 years is more appropriate, more correct, much better. Appropriate means much better. The number 1.92 times 10 to the 8th power seconds is very large. So choosing a larger unit of measure is more meaningful. The farther you are, the bigger the unit. The smaller you are, the smaller the unit. Okay? Now, please do all your examples. I see you tomorrow. We continue talking about this lesson.